Welcome to cryptography session. Today I give an introduction about exponentiation and a logarithm. We already know that exponentiation is written like this. That means y is equal to a to the power x. So any number to the power is called as exponentiation, in which a value may be positive or negative and x should be a positive value only. So this is the exponentiation representation. So this a value may also be a float, but x should be an integer one. So x may be integer and it should be positive and negative only. A may be integer or float with positive or negative combinations. So that is exponentiation. And if you want to find out the value of x, we should use logarithm. So x is equal to log y to the base e. So this is the generalized idea of exponentiation and logarithm. For example, a power k mod is equal to s mod n. And we have to compute a power k plus 1 factorial. So we already know that a power k factorial value is s mod n. And we are in need to find out a power k plus 1 factorial. So we can write the k plus 1 factorial as k factorial into k plus 1. So at the power side, I am writing it as a to the power k plus 1 into k factorial. We are also interchange the k factorial and k plus 1 value, and we already know that a power k factorial is s mod n. So instead of this value, I substituted as x. So x to the power k plus 1 mod n. So this is the generalized way of finding the value of a power k plus 1 factorial. Let us take the discrete logarithm and the combination of exponentiation. So exponentiation is mainly used for encryption and decryption of a public key algorithm. So if you want to implement a public key algorithm, there is a need of using encryption and decryption mechanism. For that, this exponentiation method is used. If you want to find out the value of that encryption or decryption, we should go for logarithm. So using the logarithm, we may able to find out order of group, order of elements of a particular group, number of primitive roots, and the primitive root values of a group. So it is possible to find out these values by using this discrete logarithm. So let us take an example. We already know that this group concept is used in symmetric encryption model. So group is denoted with a particular set and some operation may be performed on group. Here group value is Z10 and the operation is multiplication. We are in need to find order of elements. So order of element is denoted as pi of n. Here n value is 10. So 10 is a composite value. Then that will be split as pi of 2 into 5. And we are able to write it as pi of 2 into pi of 5, where 2 and 5 are prime numbers. So by applying Euler's torsion function rule 2, the value of pi of 2 is 1, value of pi of 5 is 4. So 1 into 4, 4. So totally 4 elements are possible in Z10. So the elements are 1, 3, 7, 9. Because other numbers are not relatively prime to n. So if you write elements of a particular group, those elements should be relatively prime to the given number. So by applying that particular rule, the elements of Z10 are only 4, then it is satisfied the pi of n condition. So in this way, we may able to find out order of elements. Then we want to find out, so these are all generalized form. So it is a number of element values. So pi of n is order of group. So this is order of group. I want to find out order of elements. So for finding order of elements, you take each element of Z10. So totally 4 elements are available. So I write that element and do the power operations. So power operation means you can write 1 power 1, 1 power 2 like that. If the mod value is reached 1, you stop the procedure. So 1 power 1 is 1. So order of 1 is the power value is 1. So this is order of 1. So it is 1. 3 power 1 is 3. 3 squared is 9. 3 power 3 is 27. Mod 10 means 7. 3 power 4 mod 10 is 81. So answer 1 occurred. So order of 3 is 4. Because for fourth power only, the remainder value should be 1. Like that, for 7 to the power, value is 1. So order of 7 is 4. For 9 squared, the remainder is 1. So order of 9 is 2. So in this way, we may able to find out order of elements. Then we are in need to find out primitive values. That means primitive roots. So what are the primitive root means in a group? If you take for example, G is equal to Zn star. When the order of element of Zn is same as pi of n, then that element is called as primitive root of a graph. And if n value is prime only, primitive roots are possible. So if your n is prime number, it has a primitive root. If n is a composite number, then it does not have a primitive root. So this is the condition. For example, I want to find out the primitive roots of Z7. We may able to find out number of primitive roots. So the formula for number of primitive root is pi of n. So here n is 7. So we can able to write it as pi of 7. 7 is a prime number. So pi of 7 is 6. So pi of 6. Then 6 can be rewritten as pi of 2 into 3. That is, it will be written as pi of 2 into pi of 3. Pi of 2 is 1. Pi of 3 is 2. So totally 2 primitive roots are possible in Z7 star. So how can we check it out? So before check it out, you should find out pi of 7. Then you write the elements. So Z7, so totally 6 elements are possible. The elements are 1, 2, 3, 4, 5, 6. So if you take these 6 elements are relatively prime to 7. So I am writing the element A from 1 to 6 and its power from 1 to 6. So you do the multiplication operation and you write the remainder value here. Then you just check whether any remainder 1 is available. If the remainder 1 is available at first, then you write its value. So here for 1, order of 1 is 1. So this is order of 1 is 1. Here the first remainder 1 occurred. So order of 2 is its corresponding I value, that is 3. Then for order of 3, the first one occurred at 6. So order of 3 is 6. Then for 4, this first one occurred at 3. So order of 4 is 3. Then order of 5 is 6. Order of 6 is, here it occurred. So the number is 2. So I am writing order of elements. Then I want to find out primitive root. So what is the condition for primitive root? If any element order of n is equal to order of element, then that E is the primitive root. So here A, so instead of E, I am writing it as A. So for order of n value is 6. So where it 6 occurred? It's occurred at 3 and 5. So totally 2 values are available. I already calculated a number of primitive roots. So it satisfies. So the primitive roots for Z7 cross are 3 and 5. So in this way, we may able to implement discrete logarithms. These are all few problems which should be noted for calculations. So you do your homework for calculation of order of group, order of elements, number of primitive roots and primitive roots for these numbers. Thank you.